I would like to thank our partners that extended their support to this event. Associate partners MENA Clean Energy Business Council, CETA EV Charger, who is also the panel sponsor on day one. Supporting associations: the European Association for Electromobility, Electric Drive Transportation Association, Electric Vehicle Association of Thailand. And the supporting partners: Qatar Solar Energy, Fin Value, Electroheads, the Brattle Group, Rare Group, A Great E Incorporated, and our media partner, Circuit Digest.
Perfect. Well, thank you so much to QXL for inviting me over to speak. I'll spend the next half an hour talking to you about recent work, actually still ongoing work, but in the final stages now, on trying to understand the barriers, the challenges the small and medium enterprises face to the adoption in the UK. And hopefully you'll find these results interesting, and maybe there is some learning to take away from these for other areas as well. So before I dive into the details of the project, let me give you a little bit of context behind this work and behind Ricardo. We are a large multi-industry consultancy organization. We work in engineering, technology, policy, and strategy. Our work, we're somewhat unique in that our work covers a really wide range of clients and the types of work that we do. It ranges from detailed engineering work with vehicle manufacturers and the supply chain, to undertaking strategy development for fleet decarbonization with private sector, energy companies, operators, and so on. But also we do a lot of work with national and international governments, helping to develop new policies and assess their effectiveness. European Commission is a very big client of ours, but we also work with UK governments and governments around the world. We're a global company with just under 3,000 employees around the world. We have offices in 40 different countries, but of course we work in many other countries in addition to that, remotely supporting organizations and governments in those countries to help achieve decarbonization and make good policy, strategy, and business decisions. So let me set a bit of context behind the UK situation when it comes to electric vehicle take-up. This is really the background to the project and why the project was necessary. So EV adoption in the UK is accelerating rapidly at the moment. We have approximately around 600,000 electric vehicles in the UK. And as you can see from this chart on the left-hand side, this has really increased very rapidly over the last couple of years since since the COVID pandemic has started. So we're seeing a very rapid acceleration in EV take-up. At the moment, we are about 50% market share of new vehicles sold being electric. And this is accelerating further as we are seeing vehicle availability improving. That has been a bit of a bottleneck recently, but this is now improving and continues to improve. And also, of course, prices are beginning to fall and reach parity with internal combustion engines. Alongside vehicle adoption, we have seen very rapid growth in the charging infrastructure. And as you can see from this chart on the right-hand side at the top. We're seeing growth in different kinds of infrastructure spread across public and private locations, covering rapid and regular charging. Really a very mixed ecosystem of charging infrastructure that will help to facilitate the different needs and journeys of the diverse user group. At the same time, we're seeing a very rapid transition to electric and zero emission vehicles from the bus fleet. There are hundreds of new vehicles added every year, and there are commitments from the national governments and local governments to reach zero emission fleets very soon. But all of this, as impressive as it might seem, is actually on a trajectory that falls considerably short of the UK government targets and policy ambitions. As you may know, the UK government set itself a target to reach net zero by 2040. And in order to do that, it will have to phase out sale of non-zero emission vehicles by 2035. So hybrids will be allowed between 2030 and 2035, but after that, it's only zero emission vehicles. Similarly, very recently, just over the last few days, the government has also confirmed a similar phase out of non-zero emission heavy goods vehicles. Again, from 2035 or 2040, depending on the weight class, only zero emission vehicles will be sold for heavy goods vehicles. And what this means is, in order for us to hit those kinds of targets and reach the level of decarbonisation needed, we're expecting around 23 million electric vehicles by 2032. So it's a very considerable challenge. And it's a challenge that means that every sector of the economy, every vehicle user needs to shift to zero emission vehicles even faster than the trajectories we are currently seeing. And of course, this presents a number of challenges: technical challenges, behavioral and economic challenges. And these challenges vary across the different user groups in both how they're perceived, but also how they can be addressed. One of the least understood groups is the small and medium enterprise groups of users. So businesses between 0 and 500 employees. There are many of them. They're the backbone of the UK economy. They operate a large number of vehicles, and they represent a very diverse set of business population, different needs, different fleets. They have a big impact on the economy and vehicle usage as a whole, but it's very difficult to understand this group of users. So this project was specifically set up to try and understand this group of users and what their needs and challenges are, and then based on that, try to develop ways of helping them. The project, which is called the White Van Plan. Now, the name may sound a little bit strange, but in the UK, white vans are typically associated with small, medium enterprises, with traders and other sort of business usage. And hence the name White Van Plan essentially reflects that this is a project aiming at identifying sort of business fleets and operational fleets. The project was funded by UK Power Networks, who is one of the largest distribution network operators in the UK, and it was funded through the Network Innovation Allowance. It's a program which is run by the electricity network regulator in the UK, Ofgem, and is especially to facilitate investment and activity around innovations and helping to develop a more decarbonized grid and transition to the sort of net zero targets that we have in place. So UK Power Networks had two kind of main goals for this project. One was to understand the challenges and barriers faced by the small and medium enterprises, the SME customer group. Now, they've been doing a lot of work in understanding all of the different customer groups that they serve. But as I said earlier, SMEs was a particularly challenging and little understood group. And then once we've developed this understanding, to try and forecast the scale of the EV adoption and charging demand from those vehicles, and ultimately understand how UK Power Networks can help to address some of the barriers and encourage and support the transition to electric vehicles amongst this population of users. So a quick word on who UK Power Networks is. I mean, I understand there are people joining us from all over the world, so you may not be known to everybody. It's, as I said, one of the largest DNOs in the UK. They serve approximately 8.3 million homes and businesses. And what they do is they facilitate the connection to the distribution network for those organizations and ensure quality of supply. Importantly, in this context, they also are responsible for connecting newly installed electric vehicle charging points to the local power network. So they're a very important stakeholder in this process, and often some of the biggest challenges around installation of a large number or high power chargers is that complexity of connecting it to the network, which can lead to either time delays or significant costs. And this is where we're aiming to make a difference. I mentioned this already, so it's also worth saying that for those of you who are familiar with UK geography, they cover the sort of London, the southeast and east of England regions. So it's one of the most populous parts of the UK. And as I mentioned earlier, this is part of the innovation project. Now, this is not a kind of a lone project. There is a whole program of innovation that happens through Ofgem, and UK Power Network has been very active in this program. It's carried out a large number of innovation projects. And the aim is to use this investment to identify solutions, processes, new systems that can be introduced into the business as usual operation quickly, and then help deliver those environmental improvements, decarbonization improvements, and of course, hopefully ensure security of supply for electricity, but also save money to the customers. So let's get into the details of the project itself. It's, as I said at the beginning, the SME customer group is a very diverse, a very challenging group to understand. And we knew from the very beginning that this will be a really big task. One of the big challenges is how do we capture enough information and evidence to get a good understanding of the different operational needs, the different challenges, the barriers that all of these sort of customers in this large and diverse group would face. So we've developed this approach that we've put into practice in this project. And what we've done is combined a combination of existing data and a lot of quite complex data analysis together with new research and primary research to collect data through surveys and interviews. So there are some key numbers on the screen in front of you. You can see that we've actually reviewed over 20,000 SME fleets in terms of their vehicle composition and data set for those. We've reviewed over 80 different documents and data sources to understand the key parameters, the key challenges and influencing factors, the market dynamics that affect SME vehicle usage and operations. We then did a really comprehensive program of engagement with the key stakeholders, the different industry representative organizations that represent the SME sector and the businesses in general. We've had over 80 engagements with these organizations during the course of the project. And finally, we've carried out a very comprehensive online survey, which over 1,200 SMEs responded to, and it was quite a detailed survey, so it provided a lot of insights directly from the businesses themselves. So we were able to get a fantastic level of understanding about how they operate and what the challenges are. And so having done all of that, what have we learned? It was actually very exciting and interesting to be able to have this level of understanding of this customer group. And there were a few surprises in here. So the first thing to note, so you can see on this map on the right-hand side, this is the area covered by UK Power Networks, the geographic area, represented down to the MSOA granularity level. And we found that there are approximately 2.3 million SMEs within this geographic area operating within UK Power Networks. Perhaps unsurprisingly, there was a very high concentration of these in London, but interestingly, not uniformly split across London. There was a small number of very high density areas where most of the SMEs were concentrated in. We also found that over 95% of all SMEs were actually in the 0 to 4 employee bracket. So SMEs, as I mentioned earlier, can count up to 500 employees, while the vast majority of these 95% are the smallest type of business with up to 4 employees in UKPN area. And out of those 2.3 million SMEs, we've estimated that they operate approximately 2 million vehicles within the area. And those 2 million vehicles roughly split something like 1.2 million vans, 600 cars, and 200,000 trucks, all within this geographic area. So a very large number of users, a very large number of vehicles operating and delivering business functionality within this geography. Now, because there was such a complex network of different types of businesses, we spent a lot of effort looking into the different industry sectors and understanding how they vary, what the different behaviors are, what the different usage parameters are. And we found that there is, looking just at the sector level wasn't sufficiently clear, because there were some elements very common between different sectors, and some were quite unique. So what we have done is we developed a way to segment this population based on their transportation and parking parameters. So everything that determines how they own, operate, and use the vehicles that they do. And we've created these segments. The writing may be a bit small here, but I'll just point out some of the key ones. So the vast majority of SMEs, 67%, were in the car-free segment. So if you remember from the previous slide, I said there were 2.3 million SMEs operating around 2 million vehicles. Well, out of those 2.3 million SMEs, 67 of those don't have a business vehicle. Now, of course, as individuals, they may still have a personal car, but it's not a business vehicle, and therefore it's not carrying out business functionality, as it were. So the majority, then the vehicle population split amongst the 33% of the remaining SMEs, which means most SMEs operate more than one vehicle, and actually small fleets. The other interesting finding is we found that 21% of the SME population fall into the home parkers category, as we defined. Now, this is a category where a majority of those people spend majority of their time parked at home. So these, of course, are often home workers or people that work from home most of the time, and therefore they park their vehicle at home most of the time. The other interesting one to point out is that 0.2% of the of the SME population fell into the segment of large fleet operators. So this is SMEs that operate a fleet of more than 20 vehicles. So it's a very small proportion of the SME population that operate larger fleets. Similarly, a very small proportion, also 0.2%, operate predominantly heavy goods vehicles. So now that we've developed a really good understanding of what this SME customer group looks like and how they behave, we use the information we gathered and the evidence we've collected to estimate what is going to be the likely EV uptake from this group and how this will impact charging demand and energy demand over time. So starting with the chart on the top left here, you can see that we have estimated that by 2030, approximately 30% of SMEs will be operating EVs. And then we further broke this down in this chart just below, this one here, by the segments that we have developed. Now you can see segment A isn't on this chart because segment A, if you remember, was the car-free segment, so it's not included. But you can see represented on the chart the total number of vehicles by these triangles within each segment, and then the proportions of those vehicles that are electric vans or cars, and then non-plug-in vehicles, respectively. Now, having done all of that, we have also estimated, very importantly, the energy demand from SME vehicles and how that's likely to evolve up to 2030. And so this is, you can see this in this top chart here on the top right-hand side. So what we found is that I said that we broke this down by segment, and we've estimated the energy demand. And so we found that by 2030, we have approximately just over 14 gigawatt hours of energy per day by the SME fleet that will be consumed, majority of which was by vans, and then cars, and then trucks. And of course, we have also broke this down further into the segments so that we have an understanding of how much of the energy is then consumed by the respective segments. Now, most of these segments were based on basically the proportion of vehicles within each segment, but in these numbers also included assumptions on vehicle uptake depending on each segment's specific behaviors and transportation needs. So the next thing we then try to do is to estimate what is going to be the charging demand from this entire population. Now that we understand who this customer segment is, how they use the vehicles, how they use the fleet, how they're likely to transition to EVs, and how much energy the fleet will consume. The next step was to try and understand how will they charge. Of course, from a distribution network operator, this is a very important question, because it's trying to understand where those hotspots are likely to be geographically, where a large number of electric vehicles will be plugging in and relying on charging infrastructure and connection to the grid. We've looked at breaking down by each segment the total charging by location and type. So you can see here is an example chart, bar chart, that shows you split by rapid and regular charging across each segment. We've also looked at how each segment splits between public, private, and public, home, and workplace charging. And then all of the data was combined in order to create detailed geographic maps, heat maps, where you look at this example that you can see on this right-hand side here, where we can show by 2030 what the energy demand will be from different, again, at the MSOA granularity level, what the energy demand will be from their SME fleet from charging, taking into account all of the learnings and all of the data we gathered about how they behave, how they charge, how they will use vehicles. So all of this detailed analysis, of course, is very important because it helps us to understand the demand, where the vehicles will be, and what ultimately this means for charging needs. But alongside, it was also very important for us to understand what are the barriers that these customers are facing. What is it that they're finding difficult, and how can we help to address it? Again, focusing on the role of the distribution network operator. So these are, as you might imagine, actually, each of the segments and also the sectors that compose those segments, they can have very unique and specific challenges that they face, depending on what types of vehicles they use or what kind of parking or charging infrastructure they mostly rely on, their sensitivity to costs and things like that. But there were some common themes that emerged, and so I have put them on screen here to help illustrate some of the findings. The most common and the most significant barrier faced by SMEs was, of course, cost. Small and medium enterprises, as you might imagine, are very cost sensitive. They are operating on tight budgets and tight margins usually. And so cost of electric vehicles, especially compared with the current vehicles that they use, which are mostly internal combustion engines, was a really big challenge for them. And even those that were interested in transitioning to these often found that to be a barrier. Now, of course, this is not something that the distribution network can do much about, but it is an important point to understand because it helps us, again, from a policy perspective, to make recommendations to what can be done to change and improve things. And then secondly, cost of workplace and depot charging was seen as a big barrier. Now, this was, as you again can imagine, the larger the fleet and the larger the vehicles operated by a fleet, this became a more significant barrier for those fleets. Introduction of charging infrastructure at scale required not only the hardware costs, but of course it introduced increasingly high grid connection and grid reinforcement costs. And this is an area where we clearly see a role where distribution network operators can help. And so UK Power Networks can help to inform good decisions by engaging with the SME population early in the process, and advising them of their options for having lower cost connections to the grid, or perhaps even informing decisions on what vehicles and infrastructure to choose. There were also a number of issues around infrastructure. Perceived limitations of public charging kept appearing. This is a very interesting one because most businesses who rely on their vehicles in order to carry out the business cannot entirely rely on public charging infrastructure because by its nature, it has some uncertainty related to it. Its availability, whether it's up and running, accessibility, all of those things. So a lot of the fleets that we've spoken with were clear that if they're relying on their vehicles, their first and primary recharging infrastructure is going to be private as much as possible. However, having a comprehensive network of reliable public infrastructure was seen as an additional kind of level of removing risk and giving them that flexibility if they need it. And at the moment, the perception was that it's not sufficiently well developed. Now, some of that is a perception, some of it is, of course, a reality. In practice, I think as users use these vehicles, they begin to get a feel for how much infrastructure they genuinely need in addition to the private infrastructure they have at depots. Reliance on larger and specialist vehicles, these fleets were finding it very difficult because sometimes they have specialist needs for infrastructure, either because they need more high power and expensive infrastructure, or perhaps sometimes even more bespoke infrastructure. And of course, the same is true for vehicles. Those vehicles are not genuinely available or can be more expensive at the moment. And of sticking to the point of public charging infrastructure, there's a lot of evidence came out that the rural areas and more remote areas lack public charging infrastructure in particular, and that again can be a deterrent from adoption of vehicles. And the last one that came out as a clear kind of theme for barriers and challenges to face is actually awareness. We found that SMEs are very, of course, business focused. They're typically, as we saw, very small organizations. Majority of them are fewer than 5 people. And so they don't often have the capacity, the headspace to be able to think and plan and research about the different technology options, the different vehicle options, the infrastructure solutions that could be available to them. They're focused on running their business, and these are all additional activities that it's hard for them to fit in. So there was a very clear message coming out from the SME sector that they would benefit tremendously from having access to a reliable and up-to-date source of information that can easily access as they need to, that wouldn't take a lot of their time and effort to gather their information. And again, this is something that the distribution network operator can help with. They already begin to provide these sort of hubs for information, and this could be expanded to specifically target SMEs. And if this information is available earlier in the process, in their sort of journey to begin transitioning to EVs, it can actually help inform decisions and make better decisions around what vehicles to procure or what infrastructure to procure to mitigate the risk of high unexpected costs. So in summary, having done all of this work to date, we have learned a lot about the SME sector, about this particular customer group, and we have finally understood and quantified even exactly what proportion of EV charging load can be expected on the distribution network, where it will likely to occur, how we've obviously done sensitivity analysis around all that mapping and those figures, so it gives us some idea of the variability within those numbers as well. We knew it would be a widely diverse fleet, but now we understand how diverse it is and what it is about it that makes the different segments different. And so with this information in hand, now we have a way that distribution network operators can actually reach out to these different segments and start those engagements and conversations with them to help address their specific challenges and barriers that they may be facing. We talked about the different barriers that the SMEs are facing, and costs and lack of easily accessible and reliable information is one of the biggest. And what we found is that distribution network operators in particular can play an important role in this, in addressing these barriers and challenges by engaging with SMEs early in the process, informing them of the options they have for minimizing costs of grid connection and how those can relate to the choices for infrastructure and vehicles. And of course, being a credible source of data and information that's impartial from the suppliers of the different equipment and can help kind of bring this all in one place. And ultimately, doing these things we found would have a significant impact on addressing these barriers and challenges and accelerating deployment of EVs and take up amongst the small and medium enterprises in the UK. That's all from me. Thank you very much for your time. I'm happy to take any questions, of course, if there are any.
Thank you, Denis, for that informative insights, insightful presentation. Audience, if you have any questions, either you can unmute the mic and ask him, or you can raise your hands, or or put in the chat box on the right-hand side. Here you have a question from Mr. Osbeck. In terms of cost, how much typical 350 kilowatt fast charging unit cost in the UK? Who will be paying for these units?
Yeah, so it's a really difficult question to answer, because when you get to the 350 kilowatt level, it's not equally scalable. So I wouldn't like to give you a figure for just the hardware, because it actually comes down to what's the cost of connecting this to the electricity network. These can often be actually much more significant costs, and that depends on the specific location. It depends on the grid capacity locally, and of course how many chargers are being installed and what flexibility or diversity is in those. So I wouldn't be comfortable just giving a quote for it. Part of what we've done is to assess what are the dependencies between costs and these elements. And the whole part of this project is to encourage SMEs, businesses, to engage with the DNO early in the process, so they can actually have a conversation about, in the specific geography where they're thinking of deploying infrastructure, let's say a depot, what is the spare capacity on the network? What are their options, and how are those options then affect the cost of grid reinforcement or connection that might be needed? In terms of who will be paying for these units, it's of course the business. If it's deployed on a private land for their private use, it will be the businesses themselves. There are some government subsidies available for subsidizing some charging infrastructure in workplace locations, but those will not offset those costs entirely. And yeah, if it's a public location, then of course there'll be public entities that will be paying those costs.